also have the capacity, if they are not checked, which is extremely important to remember, these cells also have the capacity to become tumors. Okay, so when anybody is thinking of getting these cells injected, unless these are done under a clinical trial, for which you shouldn't be paying, injecting when an organ is damaged, what can we do? Just like you might think, well, what can we do in a car is slightly different. So you can say, well, we'll try and repair it. It's possible. We'll try and replace it. Well, we are far too trying to say we can replace many body parts. We can't currently replace many body parts at all. We can replace, of course, you can get a bone marrow transplant. That's the only transplant, but of course, this is from some other individual and you need to have immunosuppressive therapy, or you can regenerate. Now, in the audience, people might say, but do we regenerate? We absolutely do. Every day we shed our skin and it regenerates. Our intestinal cells, they regenerate. Our hair follicles, they regenerate. So we have a significant regenerative capacity, but it's different for different organs. So if I cut my finger, or if my finger was chopped off, it cannot regrow. It would have regrown, or at least the tip of my finger might have regrown if I was in the first 6 months of life, and certainly in utero. So we do have the capacity, but it becomes senescent. In other words, it is there, but it kind of stays in a hibernative state. So I'm going to illustrate this through this video here. So this is a video of a newt, and I'll just walk you through where the limb was severed, and this is of a time-lapse photography, and you can see that the limb grows. Wouldn't be amazing if that happens to us, that if we lost a finger or a limb, it can regrow? Well, we have that capacity, but it's dormant, and we can't do that. Now, you'll see this in the cartoon frame. It's going to greet you, good morning, good afternoon, good evening, before you see the cartoon. And the cartoon illustrates it. When you cut this, what happens? So now what you then need to remember is different cell types. Stem cells have to come together. Stem cells that are going to make bone, cartilage, muscle, blood vessels, nerves, skin. Plus, it should have the information to make it in the right amount, the right shape, and coordinate all those activities. So these different cells come together in the newt, but it does in our body as well, in certain parts of our anatomy. They come together in a coordinated fashion, and they form, as you can see here, bone, and there is muscle, and obviously blood vessels, the skin, etc. Plus the shape has to come together, and you have the formation of a limb here. So this happens in life. Amphibians have this amazing capacity. Some fish have this incredible capacity, and so do we. And the question is, can we regenerate that, or can we reawaken that? Here's an example of a lady who had diabetes, and for many years had suffered with multiple ulcers, and there was no other treatment now left to treat this ulcer, apart from the fact that she was going to get a below-knee amputation. This was not done at the Aga Khan, it was done at another institution. And just as we have buildings, when you see buildings coming up, you will see there is a scaffold before the rest of the building is put together. In the same way, our cells are held together with this glue or scaffold. And the question that, and this is again done under a trial, the data is not fully yet published, but this is just an example I'm going to illustrate to you, is they decided to say, rather than putting stem cells on this, is it possible just to use the scaffold to cover this area, and then the stem cells that are around in the skin and in the other areas that are staying dormant can do what they normally would do. And this is the result within 11 weeks. So just imagine the power of this technology as and when we get it to work to the level we need it to work. And there are over 4,000 plus trials ongoing just now. And when this works, the impact of this on our healthcare, the healthcare of the populations, and particularly low middle income countries, is going to be phenomenal. Here's a lady otherwise who would have had below-knee amputation with all the other complications. So ulcers are extremely common. Decubitus ulcers, these are people who have had stroke, who cannot do much. They get ulcers on their back and they need to be treated. You can just imagine this is just one of hundreds of possibilities of what can be done. And this is not using stem cells. This is just using the scaffold to stimulate the stem cells to do what they would normally do. What about organs? And I think people are thinking we can make organs in the lab. And this is a short video that I want to share with you. And what you see in front of you is a heart valve being put together. And I hope you can hear this.
Grow your own organs in the lab means no rejection problems and no waiting around for organ donors. It's called regenerative medicine, and it's an exciting future that awaits us all.
I see us getting to a point of having options available that actually stop disease processes, reverse disease processes, or offer people cures.
Simple organs, like bladders, are the easiest to grow.
And we then created a three-dimensional mold. And we place the cells on top of the mold.
The mold is in the shape of a bladder and is made from material that breaks down in the body.
We placed the mold with the cells in an oven-like device. We cooked it, if you will, very much like baking a layer cake. And we then were able to take that organ out and we were able to place it into patients. Another of the organs that we have targeted is the urethra, which is a channel that connects the bladder to the outside of the body. It is a very important organ, as you can imagine.
Some of Anthony's patients had had car accidents, damaging their urethras. So he decided to grow them new ones. They were like bladders, really, with a different geometry. Scaffolding was seeded with the patient's cells and nutrients, and then sewn into the shape of a urethra.
And we then were able to place those engineered urethras back into those patients.
To automate organ making, the researchers came up with an incredible method. Print them. They even started out with modified computer printers.
But instead of using ink, we use cells, and we print the cells with a gel-like material, one layer at a time, and we then allow the gel to get harder over time.
They're developing another application for bioprinting, for wounds.
One of the strategies is to have a printing machine that not only prints, but also scans. So basically, the patient is first scanned, so the wound area gets a scan of the wound, and then we're able to go back with the printer and print the right layers of tissues right where they belong.
Now, for most organs, there's still a long way to go before they'll be ready for patients. But research is progressing on artificial kidneys, heart valves, large blood vessels, and skin. Here it's being slowly stretched out. They're even working on artificial ears and fingers. Predicting the timing for any research is always difficult, but it's clear some pretty exciting developments are on their way.
So you can see what's happening what's in the pipeline, and that's the possibility. Now I want to bring something to your attention, because in most of the countries that are represented, even in APAN, but really globally, there is increasing stem cell tourism offering unproven treatments. And if there's one message from my talk today is, please avoid these. This is dangerous, and this is a cautionary sign. And why do I say this? Today, around the world, there are clinics that have been set up that are offering unproven treatments, but available at a price for any of these conditions, whether it is hair loss, whether it's hearing loss, heart failure, diabetes, multiple neurodegenerative diseases and conditions, including stroke and autism, macular degeneration, liver disease, you name it, and they say you'll hear about people wanting injections for arthritis. None of these at the present time are proven, none. But you will be charged for this, and there is a huge downside to this, as I've already mentioned. Please remember, unlike taking a drug, if you have a side effect, you can stop the drug. Having cells injected into these parts, how many cells, what happens to them? And I mentioned to you, these cells can change into different cell types, including cancer. What you cannot do is, once you've injected the cells, you cannot get these cells out again. So today there are thousands of patients. The figure is probably going to become hundreds of thousands of patients every year that are being treated with cells derived from fat, or from the bone marrow, or from the umbilical cord, and being treated. And they're offered cures for stroke, multiple sclerosis, other diseases that were mentioned in the cartoon, and they charge enormous amounts of money. 20 to 50,000, I've even heard 100,000 for just extraction, culture, and preparation of these so-called treatments for cure. And there are many, many examples in the literature now of what happens with these individuals who develop cancer. They lose their sight, they have issues in the brain after injection of these cells into the brain. And here I've just cited 3 patients that developed blindness one day after they were injected with cells, stem cells that were taken from fat cells. I'm going to illustrate some examples. So a friend and colleague of mine at the University of Alberta, Professor Timothy Caulfield, has coined this term called science exploitation in the era of misinformation. Some of you, or most of you, will recognize who this lady is Kim Kardashian, who's had this vampire facial, which costs between 500 and 1,000 US dollars to get this done. And this has been linked with cases of HIV and other diseases that are occurring. It doesn't really do anything for your skin apart from give you these small ulcers. But this is not something new. Throughout man's history, we are always looking for these cures. And just to imagine, there was a time when radium water, yes, this radioactive material, used to be supplied at home in these tanks. Okay, radium water is proving a revelation of new health and vitality to some of the Seattle's most prominent musicians. And they used to sell them, and they used to do home delivery. It's like you get water now, you used to get radium water. Well, you can imagine taking a radioactive substance as water to cure. Well, I'm just going to illustrate what happened to one fine gentleman who was a known golfer, and he says here this person died. He obviously died of radium poisoning, but he says the radium water worked fine until his jaw came off. Now, you know why his jaw came off. His jaw came off because of the effect of radium. So in the same way, this is what people are doing with these so-called stem cell clinics and stem cell therapies, which are unproven. This I've taken from seminars in neurology, the growing reality of neurological complications of stem cell tourism. The emphasis is mind. Stem cell tourism ultimately exploits therapeutic hope of patients and families with incurable neurological diseases and could put them in danger the legitimacy of stem cell research as a whole. We posit that an improvement in education, regulation, and legislation, and I want to remember this piece, education, regulation, and legislation, and involvement of authorities in a global health in neurology is required. So Google, for the first time, listened to the cries of people like myself and others, and particularly the ISSCR, in stopping advertisement on Google. Unfortunately, there are still many clinics still advertising, and if you pick them, please let Google know so they can take them off. And Google says here very clearly, we regularly review and revise our advertising policies. Today, we are announcing a new healthcare and medicines policy to prohibit advertising for unproven or experimental medical techniques such as more stem cell therapy, etc. So there are then ethics that govern this. This is snake oil, just like I showed you that radium water. Here is somebody says, come all, come one, we will cure you with stem cells, which is not the case. So we need policies and regulatory frameworks to regulate these clinics. If there are doctors that are doing this, which is unethical, my personal view is they should be struck off from practicing medicine, because this is, first say, do no harm. Well, this is doing harm. But there are other things that society and cultures need to get engaged in. For example, where are we going to get organs? We can't get them from organ donations. They're just not enough to go around, and those require immunosuppression. But now we can possibly generate organs, and this has been done in animals, and that raises questions. So these are called human-animal chimeras. Just in the middle here, you can see that this rat has got the mouse skin growing here, and this mouse has got some rat skin growing here. This is a chimera, obviously did not survive, where human brain cells were growing in this particular mouse. And so the question comes up here as follows. What would be the impact? So chimeric organs, this is human organs growing in a, let's say, a monkey or some other animal, because you need the right size organs, and then they can be transplanted. You can kind of humanize the animal so there is no rejection or minimal, and can be transplanted. What society, what cultures, then this will be a different opinion in different countries and in different cultures and different religious backgrounds, which need to be respected. But those discussions need to be take place. Does an animal which has been humanized, so for example, if I needed a heart, a lung, a liver transplant, and an animal, this has been done in a particular animal, now that animal is having a heart, a liver, a lung, that is for me, but it's been humanized now, it's partly me. Does it have human rights? Can you sacrifice that animal once you've humanized it for organ transplantation? Should there be a red line which is never crossed? These are important ethical questions, and the answers to these are not easy. Science can do this, but it's a society to determine how far it's prepared to go. And the answer will depend, it'll be different in different geographies, different regions, different practices and cultures. But hence, these debates need to take place, and they should be an informed way forward. And finally, there's a question that comes up. We can also do this now. Can skin cells make egg and sperm? And the answer is yes. Before it was that we could take a skin cell and make it into any other organ, but we could not talk about making a sperm and an egg, because if you can make a sperm and an egg, you can make an embryo. The answer is this has been done in animals. Studies were done in Japan in the early times, and this has been now repeated several times and can be done. So you can take skin cells, make into an egg and a sperm, and then you can go and produce an embryo. So once you produce the embryo, you've got thousands of eggs and these have been fertilized. You can start selecting for the best embryo. So you now have selection procedure. Our parents didn't select us. We were born as whatever was conceived, but here you could select. And then you could also enhance. This is eugenics, enhance for height or memory. This is all possible. And as you know, there was a case in China of this. So these are, science is able to do this. It's for us as society to determine how far we can go. So my last objective here was, well, how can we do this science, and how have we at the Aga Khan done it? So we at the Aga Khan recognize that this is a highly competitive area, extremely important, requires resources, and requires mentors in the field. And we have built a partnership with the University of California in San Francisco. It's a partnership, not a memorandum of understanding, where we've been able to recruit with their help. It happens to be Pakistanis who have come back to Pakistan. These are renowned young scientists who then have senior mentors at the University of California, San Francisco. There is technology transfer. There is people spending time in different labs, but building capacity in Pakistan. And we need to do this right across Pakistan and in other countries, building those relationships across APAN, which is extremely important to do. And what are the advantages? Some of the advantages I've listed here, that these partnerships are beneficial for faculty, for students, for staff in the country. Networking as APAN is doing is important. It increases know-how, it helps human capital, and is financially rewarding for those countries and individuals too. So, and we know that collaboration, international collaboration, boosts citation impact, they spread across and broaden horizons, and they also offer a range of financial benefits. If it's in the most economies in the West are student-centric economic growth, and this is usually by the influx of having bright minds that create jobs and capacities. So investment in the area, both domestic and international, often follows closely behind successful higher education establishment. The other thing is these economic benefits are especially valuable for countries which have long suffered brain drains and continue to suffer brain drains. Everybody in the world, particularly the high-income countries, want our best minds. Well, we want to retain our best minds and harness them for our own economies, but working in collaboration. And so that talented young people can remain in the country and find suitable employment after graduation. And this will lead to innovation and economic growth. So I have a plea to APAN that we should try and see how we do foster this, at least in this area, as you're doing in other areas too. And finally, in the remaining 3 minutes, I put this short video to show you, to saying this is the art of the possible. You can imagine the impact on the cost, impact on lives of individuals. This is a clinical trial, still early on, but you can just see the potential impact of this.
For the longest time, it was thought that brain damage, such as that caused by a stroke, is permanent and irreversible. But a recent medical breakthrough is bringing this notion into question. Researchers at Stanford University have been blown away by the results of a clinical trial they conducted.
5 years ago, Sonia Kuhn suffered a stroke that severely damaged her brain.
This is Sonia's stroke.
It partially paralyzed Sonia on her right side, and she could barely speak.
Her speech was not very understandable. She couldn't order food or communicate well.
2 years later, Sonia could still hardly lift her arm. But just one day after an experimental treatment,
Oh my gosh.
Sonia could lift her arm over her head.
Can you move it to the side?
And move it to the side.
Are you kidding me?
And also to the front. And her words began to flow.
I woke up and immediately I could speak better.
Dr. Gary Steinberg, chair of neurosurgery at Stanford, led the small clinical trial. 18 chronic stroke patients were involved. 12 came to Stanford, including Sonia.
I was very excited. I think I started to cry.
In the trial, Steinberg drilled a tiny hole into the patient's skull and using a very fine needle, injected modified human adult stem cells around the stroke.
We put them around the stroke and that's where they do their thing to recover the function.
These cells don't survive for long after the surgery, but they appear to trigger a patient's damaged brain to begin to heal itself.
The cells somehow jumpstart the system again.
Here's another stroke patient just before surgery. And here she is just days after receiving the stem cell treatment. As for Sonia, her life is back on track. She's now married and pregnant with her first child.
And it's a boy. Yeah.
This could revolutionize our concept of what happens, not only in stroke, but traumatic brain injury and every neurodegenerative disorder. We thought the brain circuits were dead, and we've learned that they're not, end quote.
So these are the objectives which I hope I've covered and you've been able to follow through. I've shared with you the science and the potential of stem cells in regenerative medicine. I've shared with you why it is essential and necessary. You can see the economic impact on the populations of NCD, that through this research capacity, building research capacity in stem cell technology and regenerative medicine can have a profound effect on curing and also on morbidities that people suffer. It is extremely important to have appropriate regulatory policies, and I've shared why that is the case, to govern stem cell research and its application, and particularly the proliferation of these clinics worldwide, which are doing harm both to the field, but to individuals who are receiving these so-called unproven treatments. And finally, a plea to APAN, my last slide, which says, the Asia Pacific Advanced Network, which is about connecting people, cultures, research, and education, may consider to have a subcommittee that brings people together in the field of stem cell regenerative medicine for collaborative science, for innovation, for translational education, health, and economic impact. Thank you for your attention.
Well, thank you very much for covering such a wide-ranging field so eloquently, and I'm sure you've raised a number of very interesting topics. We've got a few questions that have come in. So we've got 5 or 10 minutes that I'll read these to you, and hopefully you can address them. So some are general and some are a bit more specific. So the first question that came in was, how has the COVID-19 pandemic affected stem cell research at AKU in Pakistan?
That's a very good question. Thank you for asking that. So as colleagues and friends will know, most laboratories in most countries stopped working when the pandemic came through for reasons that are understandable. We didn't do that. What we did was I discussed with my colleagues, the faculty and the staff, as to what do we do here, because it is important. We are a young institution with young scientists who really need to get on with the research. And what we decided to do is what we should all do, the following rules. Firstly, we have adhered to very strict hand washing, masking, and physical distancing. Our facilities are of the nature whereby in our labs we have 100% clean air, so ventilation is such which is the best that you can get, and also in our administrative spaces. Touch wood, we have managed to keep our labs going throughout the period. Some activities are slightly decreased, but by and large, we have managed to continue the work at the Aga Khan over literally nearly coming up to a year now. And that's really due to the vigilance of all my colleagues. And if anybody gets any symptoms or mild symptoms that could be associated, they do not come to work, they're quarantined, we screen them, and then they come back. So we have very strict rules and regulations that we follow, which really we should all be following to try and keep this virus at bay.
Okay, very good. So the next one's a bit more specific. So this person has asked about the roles of stem cell therapy in the case of chronic kidney disease. And it says stage 5 on hemodialysis patients.
Okay. So it's a good question again. As the person who's asking the question knows that end-stage disease essentially means your kidneys are not functional and you need dialysis. And the only other option is for these individuals to see if they can get kidney transplant, which I hope, if this is your personal case, I hope that your family member, whoever it is able to get a kidney transplant. In the absence of that, do we have currently any treatments that can rejuvenate those kidneys? The answer currently is no. There is significant work that's been undertaken in the field to try and grow bits, for example, the glomerulus or the collecting ducts. The kidney is a very complex organ. It's got different parts, and to try and get those all together is still some time away. But I'm hopeful, as I said, that developing organs in animals, these chimeras, is probably where this is going to go forward in, but it's some years down the line. It may be that we may be able to rejuvenate parts of a kidney using other extracellular material, but still that has not been done to my knowledge. So the answer to your question, sorry, is that at the present time, we cannot repair these organs that have been damaged to this, so it's kind of end stage and it's got no function.
One of the things you touched on during your talk was the obviously the process by which stem cells are produced, and that's been one of the, in terms of the public's perception of stem cell research, that's an area that's had quite a bit of publicity.
Sure.
Whereas obviously some of the more arcane areas people gloss over, but in this particular area of sort of embryonic stem cells compared with adult stem cells, that's been something that the public has sort of addressed, I guess, and has been at some of the basis of the ethical constraints. Is it possible to use more adult stem cells and thereby reduce that ethical question? Or are we really in a position where embryonic stem cells are required really for this research?
So both are important. However, Professor Shinya Yamanaka's work and that of John Gurdon at Cambridge, they got a Nobel Prize, and Shinya Yamanaka was able to kind of take the cells back in time and make them more or less like embryonic stem cells, for which he got a Nobel Prize in 2012. Unheard of, within 6 years of coming up with something like this. And the other thing he did for mankind at large was he didn't patent this. It's open technology, so we can all use it. So we can today, as I said, a biopsy can be taken from my skin in any lab or in our lab and converted into so-called embryonic stem cell. But we don't call them embryonic stem cell, we call them induced pluripotent stem cells. Yes, the question that comes up in that is, of course, we have put in some extraneous material, put in some genes in there that could have other effects. And hence, checking those cells before they go into anybody is extremely important, and we do that as thoroughly as we can. It takes time and it takes resources to do that. But then I would be getting back my own cells. They won't be embryonic, but it will be taken from my skin. It's been converted, let's say, to a liver cell. We have checked for that to see that it does not do me any harm. It's not had some mutations in it. And then it can be put back in my liver, put it simplistically. So the answer is the need for embryonic stem cells has significantly decreased, and also allowed us to do experiments that we could have never done without embryonic stem cells. So at the Aga Khan, we do not use, and I want to emphasize, we do not use embryonic stem cells. But it's not to say that embryonic stem cells are unimportant. They are important, and in parts of the world where IVF programs are there, embryos that would be destroyed otherwise can be worked on. But there's a moratorium on those as well. You can only work on embryos for 14 days. You cannot work on them beyond that.
Okay, another question that's just come in. The supply of organs is at 10% of demand. How will demand for stem cells be met in the future, or will it become a serious constraint?
So I don't think that the supply for stem cells will be a constraint. The supply of organs will continue to be a constraint. And as I've mentioned to you, at least I tried to put in my talk, the fact that you can develop these organs. So, and it sounds, for those of you who can imagine this, I don't want to sound that there are going to be animal factories there that you're going to be harvesting organs, but that may be one way possible to meet this demand. But that raises all these ethical questions, that when you have a chimera and you humanize them, do they have human rights? How far do we go? What do we do? This is for society to decide. And I think different countries will decide differently, but that's going to be probably, in my personal view, a way to go forward to be able to meet the demand, which is there for people who are dying, who are young, who have got many years of productive life, who are suffering because they need an organ transplant, and their families. So I think the organ transplant will be coming through that. It may be because building these organs are complex, and just through stem cell technology, that'll still take us some time. It's moved on. We've done small animal organs, but human organs are a while yet. So we should be able to address need, but through chimeras in the first instance, I think, and then as we go forward, by this time, the stem cell technologies have been such that we'll be able to do this in the lab, as it were, and have body parts ready for any individual. As soon as they are born, you have the stem cells and you can have it. It's like replacing body part or car parts in your car. It may happen in some of you who are in the audience who are much, much younger than myself. And I think in your lifetime, you probably might see that.
Okay, another question that's come in. This person has lost a relative with NUT carcinoma cancer. I'm not sure what the NUT stands for, but NUT carcinoma cancer. Are there any leads as to whether stem cell research will be able to treat deadly cancers like carcinomas in general?
Okay, so I don't know what NUT is. I'm a pathologist as well, so I don't know what NUT is. But so my group works on cancer stem cells. So cancer is a stem cell disease in my view, and there is evidence to support that. So what do I mean by this? As most of you in the audience will know, one of the things is that the reason cancer kills us is because it spreads around the body. You can treat it with chemotherapy, radiotherapy, targeted therapies, but it raises its head. The reason it does that is assuming you had 1 million cells in a tumor, and only 1,000 of those cells were cancer stem cells, only 1,000. If you got rid of those 1,000 cells, forget about the rest. If you only got rid of those 1,000 cells over a period of time, your tumor will disappear. However, what we tend to do with current therapies, that's what we have is we do surgery, we treat the patient's chemotherapy and then radiotherapy and targeted therapies, as might be the case, but we are unable to kill those stem cells, cancer stem cells, because they have the ability to escape. And so they stay there in a dormant state and then raise again and develop clones, and then you have metastases and you have growth at other places. So my group and many others around the world are working to both identifying these cells and see how we can target them, because if we can get rid of those, the answer is we can get rid of those tumors. And that's already happening for certain cancers already. So there's hope, and I'm certainly hopeful that we'll be able to do this in the future.
Very good. Well, on that helpful note and positive note for the future, I'm going to bring this keynote to a close. And thank you very much for your wide-ranging talk and making it very clear. And obviously, by the number of questions that were asked, you can see there was a lot of interest from the audience. So, so thank you once again for making time on a cold London morning to join us.
Thank you very much. Thank you to you and the committee for inviting me, and thank you for the audience as well. Thank you. All the best.
I will applaud on behalf of everybody here. So again, thank you again, and hopefully we'll meet again.
Okay. Take care. Bye-bye.
Okay. Thank you. Bye. Okay, so now we have our second speaker, Estelle Cheng, hopefully is there. Hello, Estelle, can you hear us okay?
Yeah. Can you hear me now? Yes,
Very good.
Okay, perfect.
So
hello,
Estelle, welcome
yeah.
to APAN51, and Estelle is based in Taiwan and is the Asia Pacific Engagement Manager for ORCID. And so Estelle will be talking to us about ORCID, an important thing in the research world.
Yeah,
over to you, Estelle.
Thank you, Douglas. Let me share my screen. Can everyone see my screen now? Hopefully, yeah. Here you go. Is it okay now? Let me just do the presentation.
Very good.
Okay. Is it working?
It's working, and you just need to make your screen bigger.
Okay, yeah. Okay, I'm in the presentation mode. Yeah. Okay, thank you. Let me begin. Hello, everyone. Thank you for Douglas' introduction. I'm Estelle Chen. As he introduced, I'm the ORCID APAC Engagement Manager. So today I'm very happy. So thank you for this opportunity to join the APAN51 event, to allow me to share a bit more about ORCID, to introduce what ORCID is and how it works with the research community, obviously a part of as well APAN is. So yeah, the agenda of my presentation today. So I will begin with the notion of open research infrastructure and what is ORCID and how to work with ORCID. So in today's research life, open research infrastructure is needed for researchers to share information on a global scale And open research infrastructure is also needed for organizations in the research ecosystem to share and to retrieve information on a global scale. But how to start with? To start with, we need to see how the community can enable an open research infrastructure. The key word is about sharing. So information sharing relies on network technologies, services, and applications. The use of persistent identifiers, what we call PIDs, like ORCID or DOIs, streamlines information sharing and brings transparency and trust, because PIDs anchor and reference information in an interruptible way. And combining this together, collaborations between NRANS and ORCID really can improve the research infrastructure. It can make a difference to enhance the open research infrastructure. So globally, there are some NRANs leading ORCID at the national level, like the one in UK, the one in the Netherlands, the one in South Africa, TENNET, SURF, GIS, and the one in Brazil, RMP. So the main purpose for me to share here today is really trying to encourage NRAN communities here in the APAC region to start some conversation with ORCID to see how we can move together, how we can collaborate. So next, in the next few slides, I'm going to give a quick interview of what ORCID is. So ORCID is really a global, unique, and open identifier for researchers. So ORCID's ID is for researchers and for those who contribute to research. So ORCID stands for Open Research and Contributor Identifier. It's a persistent identifier. It's like what you saw here. And regardless of changes in name, in career, in location, or discipline, your ORCID ID stays the same because it's persistent. And the second part I'm going to share is about ORCID provides a set of APIs, or what we know standard procedures, for organizations, for researchers to share their IDs with affiliations and with ORCID provides APIs for researchers to share their IDs with different organizations, especially about affiliations or activities. So what does it mean? Okay, so members, when we speak of members at ORCID, it actually refers to organizations. So ORCID's membership is for organizations. So organizations can use ORCID API to invite researchers to share their ORCID IDs by OAuth, or what we know authentication. And those members can collect information from ORCID and to connect research activities or relevant research information to the researchers' ORCID records. So using this screenshot as an example, so this member data site, they can invite the researcher Sheila to share her ORCID ID with them. So the dataset will have the permission to collect information from Sheila's ORCID records. And dataset on behalf of Sheila can connect relevant research information to Sheila's ORCID records. And this OAuth or authorization process just one time. And ORCID is really a place to store and share those different connections between IDs, research activities, and affiliations. So there, in the next few slides, I'm going to show some examples. So this is the example from our member, from the publisher, to connect peer review activities to the researcher's ORCID account. And this is the example of connecting work information to the ORCID accounts. The source comes from one of the ORCID member here in Taiwan, is National Cheng Chi University. And this is the example of connect funding to the researcher's ORCID account record. And this is an example of employment. So I think now we can better understand why PIDs like ORCID brings transparency and trust, because every piece of information you see now has a clear source and saves researchers time to manage their research information. So at ORCID, our principle is research control their data through OAuth, as we just described, and ORCID is transparent in governance, and we are really a community organization. We work with everyone. And ORCID is a nonprofit membership and platform-neutral organization. We are governed by representatives from a board. And now over 10 million researchers have an ORCID ID, and we have over 1,000 member organizations around the globe. And there are more than 600 systems using ORCID. And this is a glimpse at ORCID in the APAC. So in total, we got 115 members, and we got 136 integrations, those connections made between ORCID member system with ORCID. And we got 4 consortia, and research institutes account for most members. Yeah, so next, this is the ORCID APAC engagement team. So in addition to myself, we have another 2 colleagues here. It's Camille and Brian. And if you are interested in learning more about how to work with ORCID, there are some ways you can register a Sandbox member API to see how it works. And there are some materials about ORCID. And of course, you're more than welcome to join ORCID events. So yeah, so to make what we want to make the open research region a reality, each of us can make a difference, and each of us indeed play a role. So we very much look forward to welcoming your participation and start more conversation. I think that's pretty much I want to share today. Thank you. Let me stop sharing.
Okay, that's great, Estelle. Thank you for that. That was a nice, sharp coverage of an important topic. There's a couple of questions that have come in that if you could take a moment to answer.
Yeah,
so
no worries.
What's the difference between ORCID and something like Google Scholar or other similar type of identifiers?
Yeah, I think, yeah, okay. So I think the very important message that different IDs have very different services or different focus. So obviously, ORCID's mission is really disambiguate researchers or contributors, and we want to connect those researchers with their affiliations and their contributions. And as you may know, one of the key features of ORCID is to allow organizations to use ORCID data and to help researchers. About Google Scholar, as far as I know, it's more their primary focus is more about citation, and it's researchers need to manually maintain those stuff. I mean, you need to log in to your Google Scholar profile. And I think their focus is quite different from ORCID, but obviously there is a lot of room for collaborations. Yeah, but I would say different IDs have different purposes.
Okay. So another question was, if I'm a researcher in an institution, does my entire institution need to sign up to ORCID, or can I do it as an individual? If for some reason my institution doesn't want to, can I just do it as an individual person?
Yes, as a researcher, you can always try to sign up for your ORCID ID by yourself. You can directly go to ORCID's website because research control their data. The reason is that we work organizations because we want organizations we work with organizations to really try to build a community together. As I shared, organizations can help researchers to maintain their research information, and they can help to maintain those transparent links between different research activities. But as a researcher, you can always sign up for an ORCID for free yourself.
Okay, which brings me nicely onto the last question, which was, how do I start?
I think the very reason, if your organization is interested in ORCID, just contact us, because we are eager to know your use cases, where you are, how do you want to use ORCID. And then if you are individual researcher, we have many communication resources to teach you how to use your ORCID as an individual.
Okay, that's great. So that covers all the questions that have come in. So again, thank you for your time, and that was a nice, snappy presentation. So
okay, every success to the event.
Thank you very much indeed. Okay, which brings us nicely on to our final speaker for this keynote session today, and we're very pleased to see Eric Yen from Taiwan. Eric, welcome. Eric has been a long-standing member of the APAN community, and also the work that he's been doing in Taiwan on grid computing over the last 15 or 20 years is very well known. I think it was at the APAN in Manila in 2016, Eric, that the disaster mitigation working group was set up. And that's something that you've been very closely involved in. And I know that when we hosted APAN in New Zealand a couple of years ago, New Zealand being a land of volcanoes and earthquakes, we were particularly interested in the work that you were doing in disaster mitigation. So looking forward to hearing what you have to say to us today. So welcome.
Thank you, Doc. Hello, everyone. It's my honor to report our work at the plenary session of APAN meeting on behalf of the collaborations. I'm reporting on the topic of capacity enhancement for sustainability based on the experiences of the regional collaboration on disaster mitigations. The disaster risk reduction is a principle for the sustainability of the humanity and also the earth. The disaster mitigation working group, DMWG, aims to enhance capability of hazard risk analysis and also enhance the understanding the analysis quantitative quantification and prediction of the potential hazard risks. The primary challenge is the knowledge limitation, including other challenges such as the natural hazard is a complex system and many disaster events are caused by compound hazards. Large natural variability and also short of consistent observation data, only limited knowledge on drivers and root causes of disaster, and it's hard to do experiments to understand the processes of a hazard on the similar scale, and not enough cases for study, etc. Disaster mitigation in Asia region, natural disasters are one of the most impact in this region and also around the world. And globally, 2.5 billion people directly affected since year 2000, and 1.5 trillion economic impact since 2003, which is 240% increase over the past 30 years. So it's a key sustainability issues of most Asia country, as Asia region suffers the most total damage from disasters in comparison to other regions in the world in the past 3 decades. Extreme hazards are projected to increase in frequency and also intensity globally due to environmental changes. So how to deal with these issues? Let's start it from a bit history about the background about the working group. The collaboration of the working group, most of the partners actually started developing the e-science for hazard risk analysis with the EGEE and also EU Asia Grid projects based on the e-science paradigm from 2008. Those 2 projects are funded by the European Commission. And disaster mitigation working group was approved and operational from 2014 with the approach based on the case study, deep understanding approach, numerical simulation, and also in the future, of course, will be machine learning enabled. The disaster mitigation working group serves as a collaboration framework for Asia partner on disaster management and also broader scope. And we also actively engage local communities, the scientists of different domains, and also infrastructure, the ICT and application support specialists around the partner countries to work together. And case study will be reproduced online, and all the materials, including the data, tools, knowledge, analysis, algorithms of a case study are open accessible. That's the primary directions we are heading on. We also held different kinds of events in addition to the regular meetings in APAN, including the training, the workshop, the master class. As Doug mentioned, that we had a master class in New Zealand, in Auckland, and also in Indonesia, and also in Singapore in the past 5 years. There's one thing mentioned here is that in 2019, we have 5 events, including 2 training in Myanmar and also in Bangladesh, and also 1 workshop held in Taiwan. All these events are supported by the Asia Connect funding. So about building hazard risk analysis capacity by deeper understanding approach. In short, a case study of this collaboration aims to quantify risks and reduce at least one of the dominant factors, the vulnerability, exposure, and also the hazard based on the up-to-date knowledge of physics behind the disaster. That's the core thing of the deeper understanding approach. The regular processes cover the definition of the tasks and key driving forces, the diagnosis of the dynamics, verification of the historical events, prediction, enhancement, etc. So the outcomes could contribute to better strategy of disaster management and then reduce the impacts. The typical case study workflow based on a deeper understanding approach, as shown in these slides, started from investigation of the root cause by the scientist group when target case is confirmed. So in order to reproduce the whole life cycle of a target event accurately, numerical model and the parameterization will be fine-tuned according to the identified physical mechanisms. The expected outcome is not just a more accurate simulations, but also optimized simulation procedures, as well as observation data and the initial and the boundary conditions, etc. And good quality observation data is crucial to the simulation process design and its result. The new simulation portal will be developed accordingly, or the simulation facility would be revised following the requirements from case study. The whole process will be carried out efficiently using a scalable high throughput computing scheme over the regional distributed cloud infrastructure. And all the data model simulation portal and the event simulations are the open accessible outcomes of each case study. And the numerical simulation model and results could be updated whenever there's new knowledge to the event, new observation data, and new application applicable computing technologies. In the past 5 years, 18 case studies of 6 types of hazard in 8 partner countries had been conducted, including tsunami, typhoon, and storm surge, dust transportation of biomass burning, flood, fire haze smoke monitoring, and also lightning. The values of the case study is highlighted by the one of our coordinator on the flood hazard, Professor Jinan Liu from Malaysia, including the it's important in meteorology. It could assist in a future field program and also the numerical experiment design, and it could contribute to the meta-analysis. So other activities applying the deeper understanding approach, including the translate of the evolving scientific advancement into accurate numerical simulation, as I mentioned, and also to improve the understanding of the trends of changes of hazard impact, and also to help developing risk analysis and mitigation capabilities, and to also to build up the flexible and dynamic collaboration models of all parties, as well as the integration of analysis pipeline and improve the distributed infrastructure. And more case study of various types of hazard in different countries, and more new partners, as well as more engaged local user communities are happening. The working group will support the partners to conduct their own case studies based on their local requirements, and more data analysis-based simulation engine knowledge resulted from case study will be shared. So the collaboration also facilitates the reproduction and also resource sharing and the event simulation. And here's a list of the 18 case studies having been carried out. And for each type of hazard, the leading scientists of the scientific group have been assigned or formed as the highlighted here, and to conduct the deeper understanding of the event and develop and validate the simulation process. Now, partners such as the Philippines, Thailand, and Vietnam could conduct their own case studies based on the deeper understanding approach and contribute to the regional collaboration framework. And from the routine meetings, we support and encourage partners to bring their case studies and users to work together. In addition to sharing their requirements, case study experiences, etc., the risk analysis capability using the deeper understanding approach are growing with more case studies, advanced tools, and also knowledges. In the following slide, that there are several examples of the case studies. The first one is the case on Super Typhoon Haiyan. You can see the results here. It's a very good example for the deeper understanding approach of the collaboration. In fact, most of the life losses in Philippines were caused by a storm surge induced by the super typhoon. In addition to integrate the atmospheric model and oceanic model for accurate simulations of the lifetime process of the typhoon, the simulation problem of insufficient strongest wind speed and also lowest pressure of Typhoon Haiyan has been resolved by means of realistic characterization of interaction between the atmospheric and also oceanic layers, as well as the land-sea interfaces. And by increasing the horizontal resolution, we are able to better capture thermodynamics of typhoon, especially the eye wall structures. And so more accurate the surface flux parameterization is also realized. And here in the in this slide, there are two more examples. In the left-hand side is another case study on dust and also transmission caused by biomass burning in Southeast Asia in autumn of 2015. The simulation captures the route and also sampled concentrations of the dust 1,000 kilometer long distance transportation. The case had been verified by data collected from the ground-based gauges on high mountain in Taiwan. In the right-hand side is the case study of a 2018 tsunami in Sulawesi, which was conducted because of the complexity in source identification and also the characterization. A very fast tsunami happened after a scale 7.5 earthquake. Together killed more than 4,000 people in the northern Sulawesi. It's unusual. Such deadly tsunami was not generated by a big earthquake, happened in a long and straight trench. So according to the scenario studies and analysis, we concluded tentatively based on the observation data we could have for the moment that there are actually two tsunami sources in this event. A strike-slip earthquake tsunami dominate the impact outside the Palu Bay. And inside the bay, landslides, undersea landslide is one another possible sources. However, the exact location of the landslide is still under debate. That's a very interesting case. The last example here is the flood case study in Malaysia, conducted by Professor Junan Liu. According to the conclusion from this case study, that more test cases are needed to understand various extreme rainfall producing mechanism at different parts of Malaysia. And in the northern part of the peninsula, increased in interannual variability expected. And in certain areas, this kind of variation has doubled. And the accurate forecast of different time scales is expected to become more crucial for disaster mitigation purpose. A few more questions were induced for further studies as listed here. For example, how is the quality of the simulation affected by model resolution and moisture schemes, etc. So we anticipated for the studies and also progress on those questions highlighted here. And here is the example of the simulation portal generated from the requirements of the case study. Here is the ICOMCAT simulation portal, which is supporting the tsunami wave propagation for the scalable and high-performance tsunami risk analysis over the cloud based on the well-known COMCAT model developed by Professor Liu when he was in Cornell University. So with 9 parameters about the earthquake sources and the simulation domain and the durations are required, then users can finish their simulation and get the visualization and also analysis results, such as the initial surface elevation, largest wave height, maximum wave height and inundation, wave propagation results in animation, as shown in this slides by the web browser without any further software and or configurations. And recently, we have been upgraded the system by containerization for easier upgrade and maintenance in the long run. So the new ICOMCAT portal will be operational in later February this year. Here are some of the details of the how the accurate simulation for the Typhoon Haiyan could be achieved. I don't think I have enough time for the details, but the key point here is that the combination of the atmospheric model and also the oceanic model, by combining the weather simulation process and also the storm surge simulation process based on COMCAT model. Another example of the collaboration is that now the disaster mitigation working group has been extended the application to the agriculture domain based on the collaboration with the agriculture working group of APAN. And the project Climate Resilience Agriculture for Disaster Risk Reduction, CRDR, is a project supported by Asia Connect with the objectives to exchange the evaluation of the weather parameters impact on agriculture production for climate resilience agriculture, and also to expand the use of STI for climate smart agriculture by transferring technology, and also like to contribute to food security, livelihood, and also disaster resilience at a local level. The project will have a case study target on the Phrae province in northern Thailand. Unfortunately, because of the pandemic, the project has to be shortened to 5 months, started from January this year. So 3 more events on the training and also collaboration has been planned in the next few months by April of this year. Another example of the extension from disaster mitigation is the integration of the satellite derived products and also spatial data analysis to enhance the disaster management. Sentinel Asia is a platform to facilitate the space-based technology application to disaster management operators since 2005. So the collaboration aims to extend the capacity of disaster management and also the functionality of the infrastructure and platform. And many partners of the disaster mitigation working group also work together with NICT on Himawari satellite data mirror and applications. So we've been using remote sensing data for Earth observation and also for the disaster risk analysis and some applications. In addition to the observation and also monitoring of the weather and dust, as listed here. So because of the scales of the data needed, so intelligent and efficient data transmission, for example, supported by software-defined network, or fast data transmission from the APAN network group will be very helpful. And here is another architecture which has been planned to implement by using the Open Data Cube framework to build up the open space cloud by integrating, by implementing the geospatial and temporal coordinate systems to accommodate all kinds of informations for these applications. Another collaboration is that most partners in the working group joined the collaborations on eScience and the Disaster Mitigation Competence Center together with the EGI in the past 10 years. Now the collaboration goes to be part of the EOSC, the European Open Science Cloud, which is a digital platform for the open science applications to support easier and also flexible scientific resources. The new project is called EGI-ACE, EGIS, started from January 2021 to June 2023, focusing on the reusability, reproducibility, and also the fair open data principles. For for us in Asia, we are focusing on the disaster mitigation and also the agriculture, as highlighted in the slides. And the supporting platform over the EOS interoperable infrastructure will be provisioned, including the distributed cloud infrastructure, hybrid high-performance computing and also high-throughput computing resources, and also machine learning-based big data analytics, etc. So inside APAN, we've been working together with the Open and Sharing Data Working Group, try together moving toward the open science to achieve those objectives, as I mentioned, the reusable, reproducible, and also repurposing data and all the resources from the collaborations. Honestly, it's not easy to have so many partners working together for such a long time from early 2000. And we will increase the momentum by extending the case studies and also extension of the engagement of the local communities based on deeper understanding approach. So more Asia partners have been engaged and are conducting their case studies. More application fields from agriculture to Sentinel Asia and also disaster ecological and biodiversity monitoring, etc. More regional collaboration has been happening. For example, ASEAN, UNESCO, Jakarta office, the remote sensing, and Upper ASEAN Wildland File Spatial Research Unit, etc. So inside the APAN, so not just the application working group, such as the disaster mitigation and also the agriculture, we definitely need the collaboration and support from the open and data sharing working group for the open science paradigms. And also we need those infrastructure working group, for example, the network, the IAM, the security, the IoT, and also the cloud, to work together to achieve those targets we are aiming for. So in the future, more case studies are happening in the next few years. And capacity building for dealing with more complex multi-hazard scenarios, and also for topographical structure might be changed after a disaster, and the related data has to be updated accordingly in time, and to extend into agriculture areas, leading by Thailand and Japan from the CRIDR projects, extending the satellite-based resource federation, systematically efficiency, the authentication and authorization infrastructure, advanced data analysis, the high-performance computing by GPU, by container, and by Jupyter interactive environment over cloud are also our focus. So APAN will be the primary collaboration framework for all the partners, and also for those extensions in our plan. So collaboratively, we are able to achieve bigger goals beyond the limits of the resource and knowledge of each individual. And targeting from the regional commons is a good starting point of collaboration across boundary. And through case study and deeper understanding approach, the capacity is growing systematically according to the requirements from the partners. And from the deeper understanding approach, we are moving from the data-driven, the science-driven to the machine learning-enabled analysis facility. For the APAN, it's definitely a very helpful, active, open collaboration platform. But we also need hope that APAN could foster collaboration on regional commons and the capacity building from infrastructure to sustainability development. and to support the encourage of interactions and the collaborations of the working group to engage more user and communities from different domains from all partners around the world, and to promote the open and sharing resources by the open science paradigms. Of course, all these works have to thanks for the support from the EGI, from Asia Connect, from the NSPO of Taiwan, Sentinel Asia, and also Academia Sinica. Also, great appreciation to all the contributions from partners, including all these countries. So that's my presentation today. Thank you so much.
All right, well, thank you very much, Eric, for covering such a wide-ranging area. You know, when you think that the disaster mitigation group's been going for 5 years or so, that's an incredible body of work that you have been able to build. And certainly it has a lot of impact on the lives of people right across the Asian region. And certainly when you look at the work that you've been doing in tsunami prediction and earthquake prediction, biomass burning, it's an incredible range of things. And I was also very pleased to see that you're working together with other working groups. So the example from Northern Thailand with the agriculture working group was very interesting as well. I think we're sort of out of time now, so I think we'll leave the questions. But again, thank you very much on behalf of the community. I will give you my personal applause. And so again, thank you. Look forward to hearing more about the disaster mitigation working group in the future. So that brings us to the end of these keynotes. 3 very interesting aspects across our community: the medical, the researcher support, and obviously natural hazards and disasters. It's at the core of what APAN does. So again, thank you for everybody for speaking and contributing. Thank you again to Wakas and the team at PERN for making this particular keynote happen. And again, thank you to Andrew and the APAN Secretariat and the technical team for making this all go smoothly. So now it's break time. I think we've got half an hour or so before the next session starts. So I will sign off here and wish you all a good evening or good morning or good afternoon.
Thank you, Douglas.
Thank you. Bye.